Hello, this is William from Visual Components. In this video, I'm going to show you how to define routes for mobile robots. Instead of assigning work directly to a mobile robot, you can assign it a route of places it needs to go to during a simulation. It's very similar to a bus or a train that has a route of stations. To see how this works, in the 3D world I have a layout open, which you can find a link to in the video description. You may have seen this layout before in a previous video, but this layout has one major difference. So if we go to the first process component, select it, access its task and its process, we're creating a cylinder that has a property of 111, and then we're feeding it. But notice we're using a route keyword in its task name. So whenever you use this route keyword in a feed task, that lets the task controller know that any vehicle that visits this process component in its route can do this task. Now routes are actually managed in the Works task controller. So you can select it, go to the component properties panel, and access this tab here called route control. So this allows you to access the route table of the task controller, define a new route, so you can give the route a name, its type, what Works process components are in the route, and what resources to assign that route. Another way to access the route table and edit the routes is to click the note icon of the task controller here and go to the route control orders tab. Here you can see some documentation about the routes and different types of actions you can do, some example routes, and for this layout I've created a very simple route here. The route name is point AB. The route type is step, so the vehicle is instructed to go to a station, wait until there's work to be done there or some type of trigger before moving on to the next station. The first station is the Works process component. What do we want our mobile robot to do there? We're telling it to pick something. Pick what? Pick anything that is available there. So we're using the keyword of any here. After our mobile robot does that, it will go on to the next station. What will it do there? We're telling it to place something. Place what? Place anything that is needed there. Now, how do we assign this route to a mobile robot? Well, select the mobile robot, go to the component properties panel, and in its task list, assign it that route by name. So notice here I'm not assigning any feed tasks to the mobile robot, I'm assigning it a route of point AB. So now this vehicle knows during the simulation to execute that route, so to go from station to station in the route. So before we run the simulation, what do you think will happen? Hopefully you know, we told the vehicle to go here first, and before it can go over here it has to do some work. What work? It has to pick something. And then it will go to this station. What will it do there? It will place something. And that's the route, that's it. The route will then just repeat itself. The mobile robot will go back here, do work, then go over here, and repeat the whole process again. And that's what happens. So we'll pick up a cylinder, bring it over here, and because the cylinder of a property of 1, is needed here, it will place it there. And then go back here, and it will execute the feed task. It will pick up anything that is available, and just go to the next station. Now, with a step route, to talk a little bit more about it, when you're using a step route, you have to be aware that the vehicle is not going to leave the station unless there can be something done. So think of like a train. A train will stop at the station, but it's not going to leave until people get on the train. So that's what a step route kind of is. To see how that works, what we can do is create a delay here of 10 seconds before we start feeding the parts. So we can either insert it at the beginning or before the feed task in the process. We'll create a delay, and 10 seconds is fine. So if we run the simulation, the vehicle goes to the first station in its route, but it has to wait. It has to wait until there's something it can do there. It has to wait until it can pick something, and then it will go to the next station. And because there is no delay here, there's a straight need for it. Boop, it places the part and goes back. But once it gets back here, you can see 10 seconds probably has already elapsed in the process, so it can quickly move on. To see how that works again, select this station here. And before we need the part, let's insert a delay. So at the beginning of the process, let's use a delay of 30 seconds. Create the task, And before we run the simulation, what do you think will happen? Well, the vehicle will still follow its route. It'll go from this station to this station, but it has to wait at this station as well as wait at this station. So here the wait time is 10 seconds. So notice the simulation clock. Get to 10 seconds, the part starts moving. It gets over here, but remember there is a 30-second delay before there is a need task executed. So now there is something the mobile robot can place here. And then it repeats the route again. And because those times are defined in the process themselves, not the simulation absolute time, you can see that you'll have some variance in when the vehicle will place things. Instead of at 1 minute 30 seconds, 2 minutes, 2 minutes 30 seconds, the time can vary based on when the tasks are executed here. Let's reset, and let's actually change this route to a different route type. Well, how do you do that? Well, remember the routes are stored in the Works Task Controller here. Let's access the routes. Go down here, and you could use a route of milk. Why it's called that? It's a very good question. I don't know. But you can think of it as a train or a bus. So in a real world scenario, you would have a bus go from one station to the next station, and if there's nobody there at the station, does the bus just stay there? No, it just goes on to the next station. So when the vehicle gets to the location it has to go to on its route, it will go there, and if it can do work, it will do the work there. Otherwise, it'll just continue on to the next station. So with milk, what do you think will happen? The vehicle will get here, but remember there is a delay before it can do something. So since there's nothing it can do here, it will go on to the next station. This station also has a delay, so it will then just leave the station and go back to or continue its route again, so the route will repeat itself. And you can see, boop, nothing to do. Okay, see ya. Go on to the next station. Nothing to do. Boop. Go back here. Ah, there's something to do. Okay, let's pick it up. And go back here, and by now I think there probably is something to do. Yes, there is. Great. So it'll do the work. So this is probably one way where you might not want to lock your process or your flow of parts, so you can consider using a route type of milk. And once again, the delay here didn't correspond with the simulation time too much, so I think the next time the mobile robot gets here it can do work, but you can notice we have a block here. Because we told it to do work at this location, the mobile robot can only carry one part right now. It can't pick up this other one. So how can we fix that? And this relates to an issue you sometimes see in the forum as well as in support, where how can we tell our mobile robot to pick up more than one part? So in this case it's very simple. We just add more elements in the component's pattern. So more items it can carry. So select the mobile robot, go to the AGV tab, and for its pattern amount we'll change the x-axis to 2 and the y-axis to 2 as well. The pattern is right here. Let's offset that along the x-axis of 200 and the y of negative 200. So negative 200 in both the x and y for the pattern location, and you can see the pattern is there. So now that block we had earlier, which you could of course catch visually or with statistics, should go away, at least in this case. So let's actually speed up our simulation quite a bit. So yep, no work to be done there. So here's the one we had earlier. Yep, it will pick up a second part. And whoop, bring it over here. And this station only needed one part, so that's why it just dropped off one. You could of course run this longer to see if you get any blockage, but for now it's fine. Let's see what happens when we use create pattern and need pattern tasks. So we have more than one part that is available or needed at each station. So let's select this process component here and go to its create task. Let's replace this with a create pattern task. Let's create a cylinder, and that component name is referring to this component here. Let's create 4 parts. That's fine. And we'll replace the task. And because the component will have its name as its project ID, we have to change that for our example. So let's insert a change ID task to change the cylinder product ID to 111 because that's what's needed at the station here. The product ID of 111. And now if we run the simulation, we have the 4 parts. There's no work to be done there right now because of the delay for the feed task. Now, yep, pick up a part and bring it over here. Let's now create a need pattern at this station. So let's select our need task and we'll replace it with a need pattern. Still the same product ID. For the amount we need, let's actually just have 2 parts that are needed. And click the replace task here. So what we expect the vehicle should pick up a part, bring it over here and drop it off. And one reason I'm showing you this is eventually we'll see an issue that happens. Maybe you can guess. So here's 1 part picked, but it didn't pick the other 3 parts. Why do you think? And it places 1 part here, but not 2. That's because how the feed and need task works. So if I stop it here and take a look at the feed task, you can see the simultaneous checkbox here is not on. So however many parts there are that have this product ID, there will be a single feed request sent to the task controller letting it know, hey, pick up this 1 part. And because of that, the vehicle knows that, I only need 1 part, and that is also happening here for the need pattern. So if we select the process component, you can see the simultaneous checkbox is not on, so for each item in the pattern, it's sending 1 need request to the task controller. So after that 1 part is picked, the next request will go. But you can send all of them at one time by turning on the simultaneous checkbox. So we'll just replace the task with that change and do the same thing over here. So for the feed task, select the simultaneous checkbox and replace the task. And now if we reset, what do you think will happen if I run the simulation? Will it pick up 1 part here or all 4 parts? Let's find out. Well, we had that delay of 10 seconds, sorry. So once the vehicle gets back over here, nope, it still picks up 1. I might need to do something else, but that should... yes, okay, I understand. So we have the simultaneous option selected here. And let's check. So, yep, it's true. And let's see, did I ever forget to click something? That's what I'm checking. No, I checked it. Okay. So with the route, let's go back to the route itself. I believe we only are telling the vehicle to pick 1 thing. And yep, that's what's happening. So when we go to that first station, we're only picking up 1 thing. And in the second station, the same thing, we're only picking up 1 thing too. So that's also because we're using the milk route. So it's being told, go to the station, can you do a task? Yes, okay, do that 1 task. But now if we use a route type of force, this is a bit of a game changer in our case, because now we're forcing our mobile robot to wait until everything we need to do is ready. So if you have to bake a cake, you need a flour, egg, milk, but let's say you only have the milk. Well, do you just start making the cake? No, you got to wait until you have all the ingredients. So that's what a route type of force means. It's going to wait until each station in this route has something that can be done. And it's also listed here up the top in the documentation a bit. So now if we run this, let's see what happens. The vehicle is stuck waiting, of course. If I stop the simulation, ask yourself why. Why is the vehicle not moving? Well, with a force type route, the vehicle has to wait until everything can be done. There's work to be done before it starts moving. And this station has a 10-second delay. This station has a 30-second delay. So we're at 10 seconds and still the vehicle is not moving. That's because the other station in its route doesn't have stuff that can be done yet. But after 30 seconds, we should see some movement. And yeah, buddy, there we go. And because it's a force type route, we simultaneous send all the requests to feed the parts that are there, that have that product ID. And now it will deliver the parts. And what parts are needed here? We have 2 that are needed, and that's why it sends it there. But we have an issue here. What will the vehicle do now? Well, it's going to wait until there is a need request here at this station before going back over here. But we have another issue, you'll see, is that we don't quite yet have room for these other components that we're feeding. So it's assuming that it has to do all of these tasks. So be very careful when you're using the simultaneous option for your feed and needs with a force route. So if we want to fix this, let's turn off the simultaneous option for the feed task, replace it, and let's do the same thing for this location here. It's need pattern task. Let's replace it. So now our feed and need task are only sending a request for each item one at a time instead of all of them at once. We run the simulation again, speed it up. You see, it only picks up one part this time. And that's because in our route, if we stop it here, go back to the route, we're only telling it to pick up one thing here. So we can, of course, copy this at the first station and paste in a new section. So at the same location, pick up anything that's available. So we're going to do this twice at that station. And at this station, we're only placing one thing, so let's actually place something else. And there we go. So at one station, we're picking 2 things. At the next station, we're placing 2 things. So if we reset, we expect our mobile robot to pick up 2 items here and 2 items here. Not sure if this will work because we're using the force route. Let's see. So after 10 seconds, 30 seconds is what we need, for the needs. There's 1. And yeah, it's stuck waiting because the feed task won't send another request until that one item is being delivered. The need is already done. So this is where we have to go back and use that simultaneous option. Replace. And now, because we're sending a request for all 4 parts, after 30 seconds, there's 1, there's 2. But we're stuck in that same issue again. So one reason I'm showing you, this kind of broken logic is how you can work around it. So if you only want this robot to pick up 2 items, literally 2 items, what you can do, turn off the simultaneous option for your feed task first. For your need pattern, you could, of course, turn it on or off if you want to place 2 things, but in this case, we'll turn it off. Just make sure it's not active in that task. Then go back to your route. And with your route, you can dictate by using a step type route. So you can define each step the vehicle has to take. So instead of having to manage a bunch of different tasks in the process, you can make the route more specific of what you want the vehicle to do. So here we're telling it to step, go to the first station, pick something that's available. If something else is available, pick it. Go on to the next station and place 2 items if you can. So after 10 seconds, give me 1, give me 2. Alright, let's go on to the next station. 30 seconds, place 1, place another 1. Notice now it's not blocked. You would, of course, maybe get a block if the vehicle runs out of capacity, like you saw earlier, if it doesn't have enough space to carry more than 1 item. So hopefully by now you are a bit comfortable with the different route types, so a step route, a milk route, and a force route, and how you can edit the route and assign it to a vehicle. Let's now talk a little bit more about the different actions your mobile robot can do at a station in its route. So if we go back to the route table here, You can see you can tell the robot to pick something, to place something, to move somewhere, and to wait. So let's talk quickly about the pick and place ones. So you can use the any keyword and also specify a product ID. So at the station here, we're using a product ID of 111. Let's see what happens when we change the pick task from any to be 111. Oh, did this break everything? No, and it'll be fine, trust me. So let's actually collapse our note editor. So it's actually down here at the bottom. Run the simulation, and because the product ID of 111 is at the station and available, the robot will pick it. And we're telling the robot to place anything here that's needed, so that's why it places the items. Let's see what happens when we change the product ID we're telling the robot to pick up at this station here. So my task controller, let's tell it to pick up a product ID of 222. Oh, so let's collapse, run the simulation, and this is what we expect. It's stuck. There's no item here for it to pick up that has a product ID of 222. So if we want to work around this, you can of course change the product ID or put it back to any. Let's say we want to pick up 111. If we leave this at 222, what do you think will happen? Well, you saw earlier, the vehicle will be stuck there. So we'll pick up one item that has a product ID of 111, but there is no component here at this station that has a product ID of 222, so it's basically stuck there. So just be aware of that when you're planning a route and you want to kind of customize or define the product ID you want the robot to pick or place. So usually the any keyword is good for most situations. So yep, just send them back to any. Now for the move and wait tasks, or actions, sorry, these are sort of self-explanatory. Let's actually introduce another station to our route over here. So in the currently open source or smart collection in your eCatalog panel, you can see the items that are in this layout here, the components. So let's add a works process component here. This is our third station. And we don't need any tasks to be done here for our robot to work unless we're using a step route or a force route. So it's waiting for some trigger for stuff to be done. But off the bat, let's actually see if we can just move the robot there. So you could edit the route in the note editor here, but we can also use the component properties panel. So let's go to our route control tab here. Let's make a new route. Call it point A, B, C. Or since the third station is technically C, let's call this point A, C, B. For step, let's actually use a milk route so we don't get blocked too much. And then for our route, you can see we have this order. We want to visit the works process component here first. For the second one, we want to visit that last. So let's use the pick command here to pick the third station we added here and move it to the second spot in our list there. For the AGV or vehicle, we want to assign this route. We want to use this robot here, so you can add it to your list. Or you could just assign the route later in its task list. But for now, we'll just click generate, and that's it. So if we go to our vehicle, go to its task list, you can see it's assigned point AB, but also point ACB. So let's remove that other route, because if a vehicle has more than one route, it'll get confused. It has to just have that one route. So for point ACB, and if we go to our route table in the task controller, you can see it added it here. So let's create some space. We don't have to delete the route of point AB since the vehicle right now is only using this route of ACB. So we're using milk. Go to the works process component. What is the task we want it to do there? Let's get a bit creative. Let's use the move. And then for move, don't really think you need to pass anything here, so you could add another colon to represent the other argument needed for the action, or you could follow the documentation here and just put the keyword of any for the move command or action. And for works process 3, we could do the same thing. Move, move. Let's see what this looks like. So we'll collapse the note editor. And what we expect is the vehicle will just go from this station to this station to this station and all the way back again. So that'll be our loop. Yep, because we're using a route type of milk, it's not waiting for any trigger or all the work, everything that is needed to be done and ready before moving on. Just going from station to station. Let's now reset. And now use a wait. So once we get to the third station, location C, after we move there, let's copy this section and paste. Let's use a wait action. So we'll type in wait. How long do we want to wait for? Let's wait for 30 seconds. Collapse our note editor. And when we run our simulation, we expect that the robot will do the same loop it did earlier, but it will be waiting at this location here for 30 seconds before going to this station. And yep, there you go. So now the vehicle is at this location and waiting. After 30 seconds, it goes on to the next one. And there you go. So you could use these actions of moving and waiting if you want to really, define where you want the vehicle to go instead of using those idle locations. So sometimes you have to make a decision whether or not you want this to be done or not. With the wait task, it's also helpful if you have a certain process going on at the station that you need to wait for, and also use some signals as well. Usually you want to move to a location to get out of the way or go there before work is done, so the vehicle can just quickly do the task because it's already there. Let's now get a bit more creative with our route. Practice what we did earlier. So instead of moving to the works process, we could move there first. But let's actually keep it at milk for now. Maybe you'll get an idea of what I was hinting at that we'll do after we do this. So let's copy this line of code here. So we'll move there. Well, we don't have to move there for now. We can just go there to pick something. And then at the third station, let's actually place something. Place anything there. And the same thing for the second station. Let's place something. For the wait, we could keep it there for now. So after the component places something, it will wait for 30 seconds. But remember, this is a milk type route, so if work can be done there, the vehicle will do it. Otherwise, it goes on to the next station in its route. So yep, wasn't quite ready there, so it moves here, waits 30 seconds. Nothing is really being done at this location here, so now we can do work there. Goes here, waits 30 seconds, and then we'll go here and place a part. And that's what we told to do in the route. Let's now create a block in our process. So at this location here, let's actually select the tasks that are in this component, copy them, and insert them into the task for this process component. We don't want that delay in the beginning. And for a need pattern, let's actually edit this really quickly to be a need task. So I'll just use need, a colon, and the project ID I want, which is 111. So we only need one part at this station, whereas in this one we need a pattern of 2. So now there at least is something happening at this station. But because we defined that route, we didn't tell our vehicle, to drop off anything, to place something here. We only told it to place things here. So now we'll get a part and wait 30 seconds. Oh, actually, wait a minute. It did place it there. Let's see what happened. Did I make a mistake in the route? I placed it there. Huh. Let's go back to our route. Ah, yes, sorry. We actually did tell it to place something. I should have remembered. Here I was thinking like, what is going on? But yeah, so we told it to pick something, place it there, wait 30 seconds. We can get rid of that wait. So just delete it. So we'll go from this station, pick something, place it. But at the last station on our route, we're told to place something, but we have that issue you saw earlier where we only have one part being picked up by the robot at this location at a time. So you can see where this is going. This station is never going to get its parts. So we have to tell our robot to pick up more than one item here. So you could define that in the route. So pick any. Let's copy. And then pick up 2. So now it should pick up 2 parts. There's 1, there's 2. Drop off 1 here, but this station, remember, needs 2 parts, so it'll just keep on waiting. Drop off 1, go here and drop off the last part. And now we don't have that issue anymore where this guy doesn't get any parts. For the simultaneous, let's actually see if we can get that done. So for our need pattern, let's turn this back on so it will send the request for all the needed items. Replace the task. But remember, we're still telling the vehicle to pick up 2 items here because we're feeding 1 at a time. So if you're in this same type of situation, your first approach might be to change the route type. Let's try. So you can just quickly exit here or from the task controller. And instead of using milk, let's use step. So with step, we're going to go to the first station, pick something, and still wait there to pick something else. But remember, we're only feeding 1 item at a time right now. We're not using the simultaneous option. So for this case, what we can do is get rid of it. For the works process number 3, we're placing an item. Okay. And for this one, we're placing an item, but we have to make sure we're picking up more than 1 item here. So if we try that workaround, nope, we're stuck here. So now, what if we change the route type to be force? So now before a robot even starts, moving to a location, picking up anything, it's going to wait until all the requests have been gathered from the stations in the route. So I think we have the 30-second delay here. And we pick up 1 item, place it there, but nothing's being placed here either. So the next solution would probably be to test, okay, what if we actually do turn the simultaneous option back on for our feed task? So if we replace it, run the simulation again. So now we'll pick up 4 parts, drop off 1, and drop off 2 here. But once again, we're forcing it to wait until there is a need to go back over here, because all these stations have to send their requests. But we have the same issue again where we're locked, we can't move the robot. So if we reset, we could add what we need to the route, or change the route type again, think of something else that we could do. But for here, all I'm going to do is change this back to milk. So if the robot goes to the first station and it can pick something, pick it up. If it can go to the next station and place something, place it, sure. If it goes to the next one, it can place something, sure, no problem. So now it can pick up parts here, drop 1 off, we're still stuck. What to do? What to do? Let's get a bit more specific in our route. So we'll copy this and paste. And that's just one way to work around that issue. If you want, you can add carts or trolleys to be used by the mobile robot for picking and placing those items. For the move and wait tasks, I did promise to show you how those work with a step or a force route. So for a step route, let's change the point ACV to be step. We can pick something if it's available. We don't want to have it locked here if there's nothing else to pick. But we can try with this setup right now, where we're picking 2 items from the first station and placing 1 item at each of the other ones. So yep, there you go. And that's fine for now. But for the wait, so instead of waiting to pick up something here, what we can do is just have the vehicle move there first. So for works process, let's copy this. And then have it wait, say 35 seconds. And I made a mistake here. I need to put the route type before this. So let's quickly cut it and paste it. So we have a step route. We're going to the first station and waiting 35 seconds. Then we're telling the robot to pick something else, go to the other 2 stations and place something. And I did make a mistake here. Hopefully you can see what I did. If we tell the robot to wait, but we didn't actually tell it to go somewhere to move and wait there, then it's just going to wait 35 seconds. So we have to insert a move task before this. Use the keyword of any and move. So move there first, wait, pick something again, place something at the other stations. So 35 seconds, give or take. And yep, there we go. So you can use those move and wait actions with a step route, as well as with a force route. And here it goes again, so it's being told to move there and wait. And let's see what happens when we change our route to be force. So we're going to force it. And if we look at the documentation that's here right now, let's quickly look at this. So it moves from task to task and processes all tasks. Force route will not activate until all tasks like feeds and needs are triggered. Okay? So that's just referring also to that simultaneous action you can have for your feed and need tasks. So we're using a force route. And remember, it's not going to activate until all the requests are there. So it will move there and then wait 35 seconds. So that's one reason why I'm showing you this. And it gets all the items. But remember, it's going to be stuck because in our route, we're telling it to pick things twice. So it's going to wait for that other actions to trigger it. So we need to get rid of this. Should be fine. So once all the feed-in needs are triggered, the route will activate. Wait 35 seconds. And because we're telling it to simultaneous feed all the parts, it will take all of them. And now it's going to wait until everything else is triggered again. And then it goes here, it moves, it waits 35 seconds, because that's what we told it to do in its route. But notice, one issue you'll have to deal with is that there's not enough capacity on this robot to pick up these items. Alright, now you're probably might be banging your head against the computer saying, oh, what's going on? So let's quickly review what we did. What I'm going to do is clear the 3D world of this layout and go back to the original one. So we're at the basic step route we have for this robot. So a route allows you to tell a robot where to go during a simulation instead of directly assigning it tasks. So routes are defined in the Works Task Controller, which you can access from its notes or from the Component Properties panel. You can define a route in the Route Control Orders task here in the Note Editor of the Task Controller. You can also use the Component Properties Route Control tab to create a new route. The routes you can use, the types are step, milk, and force. Milk is like a bus or a train. The vehicle can go from station to station. If there is work to be done at that station, the robot will do it, otherwise it will go on to the next station. With a force route, the vehicle will not move to all the locations in its route until there is a need for everything to be done there. So you're forcing the robot to wait until everything can be done along that route. A step type route will have the robot go from one station to the next, but it will only move to the next station after it does work at that station or is triggered to do something. For the actions you can do at each station in the route, you can tell the robot to pick something, either by product ID or pick anything that is available there. You can tell the robot to place something that is needed there. You can tell the robot to move to that location. And you can also have the robot wait at that location. You can define more than one route, but remember you can only assign right now one route to the mobile robot. It lets it know where it has to go during a simulation, what it's supposed to do there. So if we run our simulation, this is a very simple step route. Go to this location, pick something. After that, go here, place something. After that, repeat the route. For milk, we can edit the route just by changing the route type that we assigned our robot. The route is assigned to the robot using its task list, and tasks like feed can be communicated to the task controller that any vehicle that visits the process component in its route can do the task by using this route keyword. So instead of having many different types of feed tasks with different task names assigned to a whole bunch of resources, you could just use the route keyword for your feed tasks and have the task controller and the robots figure out who does the work based on their routes. So here we're doing the milk route. Work can be done here. Work can be done here, so it just keeps on in the same loop. If you want to add more stations to a route or create a brand new one, it's very easy. Let's actually copy and paste these items here. So let's copy these two works process components. So right click copy, right click paste. And let's move them over here. And because these stations are not in the vehicle's route, it won't go there. Only these two are. So to edit our route, we can access it from the task controller. And we can add those stations to our route or create a brand new one. So let's give our route a name, point A, B, C, D. We can use a route of milk to free up the resource to not wait at a location. We can then use the list item here to select the components, either in the 3D world or from a list. List is sometimes a bit hard to see things, so I prefer to use the pick item here. And the order of your stations is the order of the route, so go here first, second, third, and fourth. But you can change the order the items are in the route using these arrows. You can then assign the route to different types of mobile robots, or AGVs. So you can use this list here to select them from a list or directly in the 3D world. You can also create the route without having any AGVs defined here and just assign it later by adding the route to the vehicle's task list. Click Generate to create the route, which is then added in its route table here. After you add the route, you have to tell the vehicle what to do at each of those stations. So for the task, you can use a pick, a place, a move, or a wait action. The items in each specific route, they use colons as argument separators, and each section in the route is separated by a comma. So at the first station we want to pick something. We then want to go to the next station and place something. And we're telling the robot in both cases to pick and place anything that is needed at the stations or available there. At the third station, we'll tell the robot to pick anything that's there, if it can carry it. And then at the last station, we're telling it to place anything it has that that station needs. If we select our robot, we can see that it is assigned the route of point A, C, B. We don't want it to be assigned more than one route because the vehicle doesn't know what it has to do, so we'll give it just that one route. And now if we run our simulation, vehicle will go to this station, pick something, this station, place something, this station, pick something, this station, place something, and then the route will repeat itself. In this case, the route type that we're using, that we created, was a milk route, so the vehicle knows to go from station to station. If there's work to be done there, it will do the work, otherwise it goes on to the next station. If we change this to force, type route, each station in this route has to send a notification to the task controller that, hey, there is work available there. And that is needed in order for this route to activate, or the mobile robot to execute that route. Otherwise, the robot will wait until it is needed to do the work. And in our case, we don't have any delays happening at these stations, so the work is available now, and that's why our robot is moving. But if we create a delay at one of these stations, it can more or less create some type of bottleneck. So at the start of the process component here, in its process, let's create a delay of 30 seconds. And now we're forcing the robot to wait until all the stations in that route have something to do, and then the robot will go into effect. And after the route is done, the route has to activate again. All those stations have to have work to be done there. So that's why the robot is stuck here. So in this case, while the robot is waiting, you could add an idle location for the robot to go to, but instead you could just tell the robot to move somewhere. So instead of waiting here, where it ends, tell it to go back to the beginning of the route. To do that, we'll just edit the route. Instead of creating a brand new route, we'll just take one section of the route, the beginning, copy it, add a comma to separate one section of the route, paste in the next section, and here we're going to tell it, instead of picking something, to move to the first station in the route. And now if we run the simulation again, we're using a force type, so the robot is waiting until all the work is ready to be done at the stations in the assigned route. So we have the 30-second delay here at this station, and after the robot completes its route, or placing an item here, it knows at the end of its route it's told to go back here and wait until the route can be activated again. And there you go. If you want to use a step route, that's like we showed you earlier, robot will go to one station, wait for work to be done there, do the work, and then go on to the next station. It won't be restricted by a delay at another station in the route. The route will activate automatically or immediately. So we can go to our route control and change this to be step. So if there's work to be done at this station, the robot will do it. Once it's done, it then is free to go to this station and do work. But remember, if there is work to be done at the station the robot visits that cannot be done, the robot will have to wait there. So notice here, the robot didn't have to wait for the delay at this station. It could just do the work immediately. But once it gets here, I guess the delay already happened, so we're not stuck there. But if we change the route for the robot to pick or place a specific thing, so if we want the robot to pick a product ID of 222 at this location, and we go back to the route, if we tell the robot to do something it cannot do, then we are creating a bottleneck or a problem or failure in our logic or our path. So if we want to pick, say, 222 product ID, that does not exist at the station. So because we're using a step route, and we have the logic there to pick an item of 222, the robot can't do that, so we're stuck with the robot here, just waiting, waiting, and waiting. So you might want to troubleshoot and use a different route type at first. So you can say force. So if we use a force, remember the robot has to wait until all the work is ready to be done at the stations in its route. And even though we had that delay of 30 seconds, there is no part being fed from this station that has that product ID of 222. So the robot is not going anywhere. So if we try changing the route type to milk, this does free up the mobile robot to go from station to station to see if it can do work. And you can see it starts moving. But once the robot gets here, that product ID does not exist, so it just goes on to the next one. And that's another reason why I can't do any work here, because it needs a part, but the robot at this point doesn't have anything there. So even though we changed the route and the robot is moving, it's still not, picking up any parts or placing them at the end of the route. So we can actually go to our station and see if the error lies there, that we need to actually feed the right part. So instead of feeding a product ID of 111, we can change the ID of the part to be the one we need on the route. So just edit the create task to give the cylinder a product ID of 222 and replace it. And if we run the simulation again, you can see we changed the route type. We made the product with the new product ID, but we're not feeding that. That's why the robot's not picking it up. So even though we changed the product ID, we still have to change the feed task itself, either by listing it as another product ID, like this, or just feeding whatever is there in the station, everything. So we actually can clear this out and use the all checkbox and update the feed task. And now our robot, when it gets to this location, it knows that it can pick up 222, which is now available there. But remember, it's not needed here, so it keeps onto the part, and now we have another issue where the robot does not have any space to pick up any more parts. So here, the issue now lies at this station, so we have to change what is needed to be that product ID that we defined in our route. So update the need. Run the simulation again, and we're back to what we had earlier, a working solution. But in the long term, it just depends on the approach you want to use for defining your vehicle routes. Okay, this completes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.